Right. Well, I'm delighted to be here tonight and tell you about RChain and how RChain might be the platform that could provide such an infrastructure that we need for such problems like global warming for global coordination. And I want to talk about how RChain can scale like nature. So, first point, all this information within this talk is not meant to be any trading or investment advice in any kind. Yeah. So, just a few words about me. I'm Philipp. My background is in physics, so I studied physics. And then I stumbled upon Bitcoin in 2010. At that time, I really didn't get the concept behind, and I really thought this is just a short-term phenomena and will just disappear in near future. But yeah, I started mining and then forgot about that. And heard about Bitcoin again in the end of 2013 when the price skyrocketed about 1,000 US$, and tried to recover my private keys from the Bitcoins I've mined, but yeah, I'm one of those guys. But luckily, short after that, Ethereum came around, and I've read the very first blog post by Vitalik at that time, and it was one of those moments where you have just a mind explosion, just as Rinke said. So I was really blown away by this idea that one not only could have a decentralized currency and not only build for every decentralized application a new blockchain, but rather to have a blockchain where you can build your applications on top. And I contributed to the Ethereum project, especially during the stress test and testing phase. And yeah, since then I'm involved into the Ethereum ecosystem. Short after that, I started to focus more about, or shifted my focus more, also my academia focused more towards computer science and focused on game theory. So, and mechanism design. And lately, I got involved into RChain because I think we've learned a lot through the last years, and there's some problems within the blockchain space, and some were mentioned here by Tim before and Rinke. And I think that RChain could, by his approach, be that kind of platform that Tim was talking about. So, and I'm also involved into inblock.io, which is kind of a gathering of blockchain enthusiasts, which provides some services around that. Yeah, and also an organizer of a Meetup in Hamburg. So, just to point up again the lessons learned within the last 3 years. So, lesson 1 is proof of work as a consensus algorithm is rather simple, but is definitely not sustainable. So, you've definitely heard about that the energy consumption of Bitcoin is enormous, and yeah, so that's not sustainable, specifically if we're talking about global warming. That's not the way we should go, in my opinion. Then there is the second lesson, and maybe it was a hard lesson to be learned for many people in the crypto space, that writing smart contracts, buggy ones, is easy, write correct ones is pretty hard. And so, for example, there were within the Ethereum ecosystem, there were some bugs within the multisig wallet of parity, or for example, the famous DAO hack. Yeah. So we need some kind of tools to build decentralized applications in a secure manner. And then there's also the lesson learned, which is no blockchain scales. And that's the truth. And if anyone currently says otherwise, well, I guess, in my opinion, he's lying. So no blockchain scales. And just as an example, there was this tradable card game, CryptoKitties, which clocked the whole Ethereum network. So yeah, that currently is no blockchain scale. So how can come RChain into this game? So RChain, as Ethereum, tries to build a general smart contract platform that provides the ability to build applications on top in a secure, sustainable, and scalable manner. And the approach is pretty scientific and mathematic. So topics in this, there are topics talked about category theory, computational calculi, or linear logic. And yeah, another methods used to build this platform is corrected by construction, so that you bring up axioms, and then you prove going on the very sound principle every step, and then you end up with a system which almost is self-evident to construct. So there is a way, more or less, that is, it is basically given out of this construction. So I want to talk about how RChain takes principles out of the nature, how nature scales into account. And if we really go and look how humans work, basically. So let's take a deep dive into our body, and we end up just zoom in, and we end up at a level where there are atoms. And those atoms could make a connection in a way, and by passing electrons, and then there's some bigger structure which is called molecules. And molecules themselves can arrange and organize into bigger stuff like cells. Cells themselves can specialize and then exchange, for example, chemicals and form some bigger structured tissues, and this goes on. So there are origins where hormones in the body regulate all these functions. So you see, there is one principle, and this principle is that you build bigger and more complex structures out of smaller things. So this is called compositionality. And then there is a different, or let's take another example first. So one other example in nature is, for example, ants. Ant colonies are amazing in multiple ways. I just want to point out one thing they can do. They organize more or less in a decentralized fashion. So each ant is in itself, of course, an organism, and the whole colony in itself, but is also kind of an organism. You can see it like this. And they're amazing, but they can build like bridges by just clocking them together, and then they can run over a gap. And they do it by exchanging messages of how's it called? Pheromones. And so that they signal in a way what the other ants should do. And so there is a second principle we can derive, that coordination somehow also in our body is done by passing messages or signaling. And this is basically how, in a way, something is achieved in nature. And there's a third principle, which is, if we're going back to the body example, then your body, your cell in the brain, or the cell in your heart, doesn't need to know what a cell in your toe is doing or whatever. So there is this kind of principle that there are a lot of interactions going on the same time, but they're mostly not dependent on each other. So this is the principle of concurrency, so that you have processes going on at the same time without without having the need necessarily to order them in a way, or to sequentialize them. So yeah, here are the three points we can take as the principles we can come up with if we take a close look at the nature. And it's like it's a little bit weird. Like it seems like that everyone has forgotten how things work in nature when we entered the blockchain space, because in a way blockchains are not fulfilling currently any of these needs. So, for example, take Ethereum as an example. They're running on one machine that's run the one world computer example, but all those kind of transactions are sequentialized. So there needs to be one kind of an order, because the underlying computation model is the Turing machine, or to be precise, the von Neumann machine. So it is essentially a sequentialized machine. And how does this ever gonna be scalable? It's incredible. Another point is that kind of compositionality within the computation model of a Turing machine is not given. Yeah. So just one example, sometimes there's a little bit confusion between concurrency and parallelism. So just as an example, take a highway with 4 lanes, and parallelism would be that you have 4 lanes, for example, and no lane crossing is allowed. And concurrency on there, so this would increase the overall performance in a way, compared to a highway which has 2 lanes. But on the other hand, concurrency would mean in this context that lane crossing would be allowed, and in order to do so, you would need to signaling in a way, so you have some kind of blinkers, and then you're signaling the other car that you're trying to cross the lane, and so the car needs to make a little bit space that you can cross the lane and change the lane. And that's concurrency. So concurrency is about resource management in a way. So when we come back to a platform that needs to be scalable, one can ask the question, okay, how does a computation model for a scalable blockchain should look like in this domain? And we've come up with 2 properties already. So it should be concurrent, and it should be compositional. And there are 4 other properties, 2 other C's. Greg Meredith called them the 4 C's. There's the notion required to tell something about the complexity of a program. So how much resources are need to run them, or how costly is it to run a program. Especially we're given in the context of a blockchain, where in order to avoid denial of service attacks, you have to pay for the computation. Therefore, you need some model of measuring the execution, or the cost of an execution. And then there is completeness. You know completeness maybe from the Turing completeness in that way. So to be precise, one wouldn't really need completeness. Vitalik came up with the term rich statefulness, but for the simplicity, you just call it completeness. And so that this says that you just need a way to build arbitrary programs, so that you can every program we can think of, you can build on this platform. And then there are two other properties. It's type theory, which is important in order to prove with formal methods that a program actually does what you think it does. And metaprogramming, which is that you want to have the ability to write a program which then writes programs. And most programs within the industry are written by programs nowadays. So these are the requirements, and now we can look. Okay, we have some computation models out there, and I mentioned one before. That's the Turing machine, and we can, for example, and Ethereum is based on a Turing machine, and most computers are Van Neumann machines, which are based on Turing machines. So, completeness, yes, Turing complete. Compositionality, you can't whack two Turing machines together within the context of a Turing machine, get a third one. Concurrency, nah. And this is also nah. Yeah. And type theory and metaprogramming, not really. So what kind of other computational models are out there? There's a lambda calculus, and every functional programming language is based on the lambda calculus. And yes, it is great for compositionality. It's also great completeness, yeah. Complexity, nah, not really. And concurrency, nah. There's a theorem that every functional programming language, there's a theorem that's derived from the lambda calculus that basically every functional programming language is processing sequentially. So there we have it. Lambda calculus, not that good. Then there are some other Padrinets, CCS or whatever. Turns out that the only computation model that nearly fits all those criteria is the pi calculus. But the pi calculus does not have the metaprogramming requirement. And turns out that Greg Meredith, the thought leader behind this project RChain, came up with an idea to enhance the pi calculus, the process calculus, and give the option to have metaprogramming as well. Yeah.
So how long ago were pi calculus and row calculus invented?
Pardon?
How long ago were the pi calculus and row calculus invented?
That's my next page, basically. Okay, yeah. So, yes, there's another question?
You talked about one of the requirements were complexity.
Yeah.
Can you explain that again?
Complexity is you need a way to measure what kind and how many resources a program needs to be executed. So, for example, that you can say, okay, this program requires X amount of gas within the scope of Ethereum, for example. That would be the example. So, yeah, you need a way to measure how expensive it is to run it. that's meant to be, in this context, complexity. So a little story about computational calculi. Robin Milner came up with the idea of a pi calculus, process calculus, first in the beginning of the 90s. And his idea was, well, let's build a better computation model that describes the way actually our computers are processing better. So at that time, even there were some machines, and each machine was processing a piece of that information and pass a message with that processed information to another machine, and so on. So he thought about, okay, there's some messages to coordinate. Let's try to build a computation model that actually describes this overall process. That we have different kind of machines which talk to each other. And let's try to build a computation model that takes that in. And it turns out that it is possible, not only that the computation in itself is done by passing the messages. So you really can make a computation model where just the passing of the message is the actual processing. And as I talked before about, nature in a way takes a similar route. And it was then to Greg Meredith in the beginning of the 2000s that he invented the reflective higher order process calculus, so the row calculus, by adding reflection to these computation model, which gives the opportunity to do meta programming. So, in a really simple way, I just want to introduce you to the row calculus, and it's pretty. You can have a pretty good intuition about that. So there's a way to describe doing nothing. We all know doing nothing is great. So doing nothing is somewhere there. So then there's a way to listen for something on a certain name and then do something. There is a way to describe to call someone, for example, and send him something. And then there is the way to do two things in parallel, so multitasking. And at the bottom line, there is a way to get a certain information about something that's referenced. For example, look up, it's not the best example, but look up, for example, a phone or the person who owns a phone by the phone number. Or open a book at a specific page and look what's in there. So hopefully you have some feeling what it is about, because next is the formal way to say exactly the same. So P and Q are called processes, and there are multiple options. So that's a notion of describe multiple options. And P and Q, for example, could be the process to do nothing, to terminate. Or P and Q, the process can be, for example, listen on a channel Y for a pattern X, and then do the process P, which in itself could be something of these four. And there's the notion to send something on channel X, and this send P, the process P, on channel X. There is the option to have two things done in parallel. So have P run in parallel with Q. So two processes run in parallel. And then there's the option to give it a certain name. And if I call something name or channel, that's basically the same. So given a certain name, evaluate this name or this channel and get the process. And there's also the possibility to get a name from a certain process by quoting it. So that's basically the formal way to describe it, but hopefully you got something from the intuition example if this is too much math. So from this computation model, which is inherently concurrent, one can derive a programming language. And this was done, and this is called RChain, and there will be talks about that later. And the syntax of this language is pretty similar to the formalism. So roughly the same syntax. In the beginning, so the RChain project is gonna launch at the end of this year, and there is the plan to have spatial types in there, so a way to reason about a structure, or something something similar like regular expressions, not really 100%, but goes in that direction. And there will be behavioral types later. And behavioral types are very interesting in a certain way because it is a type that says you something like the program behaves. And this is really interesting because if a software developer has an idea to program a smart contract or a program in general, he has an intention in mind. He then writes a specification for that, and then after, or maybe he skips that part, but just assume he rewrites a specification, and then he writes the implementation. And if you want to have a correct program in this whole reasoning, this line here, there can be done an error. So what behavioral types is interesting for is that you have another way to check whether what I've actually implemented fits to the thing that I specified or that I had in mind in the first place. So I really can see by looking at the program and at the type whether the program behaves in the way I intended to. It also gives a very expressive way to use formal methods to prove that the program actually does what it should do. Another one could come up with other interesting use cases for that behavioral types. Another would be, for example, that you could have such, if you want to, for example, if you have GitHub and you want to look for a project and want to use a library, well, it's kind of difficult to find one that fits your needs if you don't know what to look for, other than you were given a hint that you look for project X or Y. And so what you do on GitHub, for example, is search by text. And that's pretty terrible because what should you look for? I mean, you can look up for certain code snippets or whatever, but what you really want to do is find a library that does something I want to use. And you could really use behavioral types for that, because then you can just use this kind of type system for look for programs you want to use or you need a library for a certain behavior. And that's also a different kind of notion of scalability, that you don't have to reinvent the wheel again and again, so that you can use the programs that are already written there. So what about scaling, and how does this concurrency within the computation model comes into existence within the structure. So RChain is going to have a very expressive namespace system that I like to call sharding on steroids. So sharding is interesting because you go away from this notion of having one blockchain and every validator validates every transaction, but rather have a blockchain and some other blockchain nested into that. And namespaces, so what Ethereum does is it kind of artificially built this kind of sharding on top of this EVM, Ethereum Virtual Machine, which is, as I said, a sequential, is based on a sequential computation model. And RChain, on the other hand, is based on the row calculus, which is inherently concurrent. So this namespace system wasn't artificially invented on top. No, it's in there into the mathematic algebra formalism. It was there in the first place. And it turned out that the formalism in itself is pretty good in the domain of blockchain. So how you can think of these namespaces is like, it's kind of similar to URLs. So you have a way to find or to reach a certain resource at a given location, and these locations can be nested. At the launch of the project, there will be 30 regions, and think of regions as the place which is inhabited by the validators. And so if you want to become a validator within the RChain ecosystem, you register for one of, or maybe multiple regions, and then you're a validator in that region. And the namespaces, on the other hand, the set of namespaces is the power set of all the regions. So that means that the validators for a given namespace, for example, that is for a given namespace where X and where you want to have a resource out of X and Y, you have the combined. You have to use the validator sets of both namespaces. So that means that if you want to have a transaction that is cross different namespaces, obviously it is more expensive because more validators need to coordinate. Yeah, and basically that's it from my side. I hope you learned something about how RChain actually tries to go a different route in the sense of scaling, and basically does its approach is quite similar what we can see within nature, for example.
We have
5 minutes for questions.
Yeah.
5 minutes for questions.
Yeah, Pascal. Oh.
But we have the live stream, so we do the microphone display.
So you became famous by breaking Ethereum in its first versions. Have you tested your skills on RChain already?
I'm not currently involved into testing and that kind. I hope that when the testnet is released, that there will also be kind of a stress test, and then I will get my hands dirty again. Yeah. So
the testnet is an actual network, but the software, is it ready with it? I mean, can you set up private testnets?
Pardon?
Can you set up? Is the software ready? Is the client ready? Can you set up private testnets?
So the current project status is that there is not that kind of way to have a testnet running that far. So at the given point, no. But in the summer, late summer, this should be possible, yes.
Okay.
Okay. So you mentioned like for verifying. So say you have a DApp that has applications today have like many dependencies, which in turn have many dependencies. So you could end up with an DApp that has like hundreds of dependencies.
Yeah.
How will that work if for verification? Will it still be in line with other blockchain solutions?
So if you want to bring, if I understand you correctly, it is the case that you want to have, or you give an example within the Ethereum context, and you want to bring that kind of program DApp over to RChain, and how this gonna look like within the RChain context, or
consider if you have a C application, maybe you have like a library like Boost, or if you have a JavaScript application, you maybe have a library like Connect or Express.
Yeah.
And so yeah, like.
All right. So as I said, this computation model is inherently concurrent, but sometimes you need to sequentialize, or you need an order of things. Then you can say explicitly for this case, okay, do that sequentially. Do this kind of processing sequentially. So that gives you the option to have such programs that there are certain dependencies also within the context of the row calculus. One important point is that with the concurrency, and for example, if you run two processes in parallel, you cannot come up with a situation where there's a congestion of resources. So you have this kind of notion of non-determinism. And this non-determinism is resolved within the layer of consensus. So within the consensus, it is defined what actually happened to resolve this possible non-determinism that exists within the scope of this computation model.
Maybe some direct updates, because to have that straight, the official information about test and release are indeed July this year. But I think this is very optimistic, so we will see if we can keep that timeline. And the other thing is the node communication for running a testnet, so that node-to-node communication is going to happen, is planned on the 0.4 release, which is currently at work. So it's currently being in the progress of being built, and the release date is at end of this month, beginning of next month. So we will see.
0.4.
0.4.
Yeah.
Yes, that's correct. Okay.
So one more question, I think this is the last one, and there will be more presentations where hopefully some more things will be clarified. Yes.
Especially we'll have a talk about rolling, because I really didn't touch rolling in itself.
So it looks a lot like you took a Scala-like language model, in that it's sort of self-hosted, runs itself. It's like, rather than Faro, which runs straight on the machine, it runs straight as a blockchain. So it's very Scala-like. But then you decided to just throw a currency in there and say we'll use Casper to sync it all up. And it's basically pub, sub, and fork. That's it, guys.
Yeah. Almost, yeah.
Is there still a question?
I'm sort of like, do you expect that, do you want this Scala-like model where you're just like really independent, doing your own little thing?
I mean,
Because
Scala in itself is
like,
a functional
because you
programming
haven't
language.
talked about language bindings either, which is like the first next thing if you have a very basic layout for like doing concurrency, is to bind like existing software into your model for concurrency. And I'm a little bit lost as to what the advantage is over doing Go fibers or Node.js events.
Yeah, I guess there will be a talk.
Have the option to ask the right person for that.
Yeah, I guess there will be a talk about rolling in itself, and I guess just ask the question later. I guess that's more.
Well, it's much worse when you talk about the like cryptocurrency that goes with it, because it looks like you took a Scala model, an incomplete functional programming language, and you bolted a blockchain on top.
Well, that's not really the case.
It's
But
probably not, but you only talked about the language.
yeah, I
so-
guess we can have a discussion about that later, or maybe it is answered within the other talks.
Sure.
Okay, so thank you. So we welcome discussion. I mean, that's important. This is very experimental. This is the very first time that we put a blockchain on top of such a language, even though actually this PyCalculus is existing already also in production. Microsoft, Google, they already built system on top of a concurrent programming language. So it's not something new, but to put it on a blockchain is something completely new and maybe gets more attention now.